Hello my dear bright minds, welcome back to our physics class. Today we are going to discuss something very important topic, that is characteristics of waves. So just like waves in water or sound in air, these special properties help us to understand how energy travels. So here we begin with the characteristics of wave. So next concept is all regarding the characteristics of wave. The first character, let us discuss something regarding the phase. Children, do you know what is meant by phase? Yes. So, the points of a wave which are in the same state of vibration is called as phase. I repeat, the points on a wave which are in the same state of vibration are called as phase. In order to understand this clearly, let me explain you in detail. So, let us consider a wave. Moving along x-axis. Consider a wave moving along x-axis. Suppose a wave is moving something like this. Here if you observe carefully, these two points resemble the crest, whereas these 2 points resembles a trough. So what a phase is? Let us try to understand what is a phase. This is the wave. On the wave, the points which are in the same state of vibration. So these 2 points are in the same state of vibration. These 2 points are in the same state of vibration. So in the previous class, we have discussed that whenever a transverse wave passes through the medium, then the upper ones are called as your crest and the lower one, the depressions, are called as your troughs. That means the points on the crest, all the points that lie on the crest are in the same state of vibration. Similarly, all the points that lie on the trough are also in the same state of vibration. Children, not only this, I would also like to explain something more than this. See, here if you observe, again here and again one more point here, this green color also we can say that they are in the same state of vibration. One more particle would you like to take something like this? So this is moving up, again here it is moving. This pink color even resembles the same. So those particles which are in the same state of vibration is called as phase. Okay, and best example for this is all the points that lie on the crest are in the same state of vibration, whereas all the points that lie on the trough are also in the same phase. Okay children, so what is a phase, children? The points on a wave which are in the same state of vibration. The points on a wave which are in the same state of vibration is called as phase. So now let us try to understand in detail regarding the time period. So what is time period, children? The time taken by a vibrating particle for one complete vibration. I repeat, the time taken by a vibrating particle for one complete vibration. Here also we can explain the same. Okay, 2 examples I'll be explaining, children. So this one, suppose a particle is there, it goes up, again it comes to its mean position, again it goes down, and again it comes to the mean position. Instead of that, I would also like to take one more example, children. See here, let us consider a longitudinal wave is traveling along the medium. A longitudinal wave is traveling along the medium. So whenever a longitudinal wave travels along the medium, we know that all the particles of the medium, this one, this one, this one, this one, and so on, all the particles of the medium vibrate to and fro, back and forth, forward and backward. So if you consider only one particular particle, say something like this, this particle moves forward from the mean position to the extreme position towards right, again extreme position to the mean position, back to the left side extreme position, and coming back to the mean position. The particle starts vibrating from this mean position, going the one extreme position, again coming back to the mean position, again to the other extreme position, and coming back to the same mean position. So how much time is it taking to finish that particular vibration? Okay, the time taken by a vibrating particle for complete vibration is called as your time period. In other words, I can also explain the same like this, children. So here if you consider the particle, it from the mean position goes to one extreme position, coming back and again down. Meanwhile, what happens means a complete wave. So wherever it starts from, goes to the extreme position, again to the mean position, and one more extreme position, again to the mean position. Starts from the mean position, covering both sides, coming back to the same mean position. This forms a wave. Okay. So the time taken by a wave to produce, the time taken by a particle to produce one complete wave. I repeat, the time taken by a particle to complete one complete wave is called as your time period. Generally, time period is indicated with the letter T. Time period is indicated with the letter T, capital T. And T means time period, and SI units of time period is seconds, indicated with the letter seconds. Symbolic notation is yes. Clear, children? So what is a phase? The points at which all the points which are in the same state of vibration is called as phase. And the time taken by a vibrating particle, to produce one complete wave or one complete vibration is called as time period. Okay, represented with the letter T. SI units for time period is seconds. Okay. Children, suppose that a wave is produced. In order to produce a wave, suppose it would have taken 2 seconds. How much time it has taken, children, to produce a wave? Let us suppose that it consider 2 seconds time is required to produce one complete wave. Then it will be the time period of that. Suppose, in other words, I would like to say you that in 1 second, this will be better example, children. In 1 second, let us suppose that 2 waves are produced. In 1 second, how many waves are produced, children? In 1 second, let us suppose that 2 waves are produced. Then, what is the time period of the wave? The time period of the wave is half second, because 1 second, if 2 waves are produced, how much time it takes to produce one wave? So, one wave is produced in half a second. Half a second means 0.5 seconds. So what is the time period for this case? In this example, the time period is taken as 0.5 seconds. Is that clear, children? Okay. So that means if 2 waves are produced in 1 second, the time period for one complete wave to produce one complete wave will be 0.5 seconds. So this is all about your phase and time period. So these are the characteristics of 2 characteristics. So now after that, let us try to understand something regarding the frequency. Okay, so the total number of vibrations per second is generally called as your frequency. So let me write down that frequency. So what is meant by frequency? The total number of vibrations per second. So the number of vibrations per second is simply referred as your frequency. Or in other words, the number of complete waves. Either you can say it as the number of vibrations per second, or instead of saying number of vibrations, you can also say it as a number of waves. The number of waves or the number of cycles per second is also called as your frequency. Number of waves, number of vibrations, number of waves, number of cycles per second is called as your frequency. So this is a number of vibrations. The particle starts from mean position, going the extreme position, the other extreme, and coming to the same mean position, one vibration. So this is a wave. At the same time, the wave goes one extreme position, again mean position, to the other extreme position, and again to the mean position. So one complete wave. So that means in 1 second, how many such waves have been produced, or how many cycles has occurred, or how many vibrations takes place is defined as your frequency. Okay. So this means in this case, 2 waves are produced in 1 second. So number of waves produced in 1 second is 2 waves per second is the frequency of that. For example, in this case, if let us suppose that Here how many waves are produced, children? 1, 2. Only 2 waves are produced. So let us suppose this time period t as some 1 second. In 1 second, how many waves are produced? 2 waves. So 2 waves are produced in 1 second. So what is the frequency? 2. Similarly, instead of this, let us take one more example. Again for the same time, let this time be 1 second, children. From here to here. Okay, up to here, let us see how many waves are produced. Going up, down, 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 up, down. So, again in the 1 second, how many waves are produced? Let us try to count out the same. So, this is 1 wave, second wave, third wave, fourth wave, fifth, sixth, 7, and 8. So, how many waves are produced in 1 second, children? Totally 8 waves are produced. So, in this case, the frequency is 8. The frequency is 8. Whereas in this case, the frequency is 2. Okay, but what are the units of frequency? SI units of frequency is hertz. SI units of frequency is hertz. Symbolically, it is written as Hz. Okay, so what is the frequency of this wave, children? 8 hertz, and here 2 hertz. SI unit of frequency is hertz. It's named after the scientist hertz. Okay, so well, and that's it, children. Now moving to the next one. One more thing I would like to, children. The frequency of a wave is always fixed. The frequency of a wave is always fixed. So its value does not change with respect to the substances. Suppose if the same wave passing through the different substances, but even though it passes through different substances, its frequency will not change. Whether it is solids, liquids, gases, vacuum, anything, the frequency always remains same through all the substances. Clear, children? So, well, next one is one more thing I would like to tell you. It does not depend on the value of the velocity, amplitude, or the nature of medium. Frequency does not depend upon the velocity, amplitude, or nature of the medium. Any medium you consider, the frequency remains same. Okay, that's it. So, whatever be the amplitude, so amplitude will be learning in details. Velocity of the wave, amplitude of the wave will be learning in detail. So first of all, I hope you got a better knowledge regarding the phase, time period, and frequency. What is phase, children? All the points that which lie on the same state of vibration. All the points that lie on the same state of vibration is called as phase. Okay, so now what is time period? The time taken for one complete vibration or time taken to produce one complete wave is called as your time period. What is frequency? The number of vibrations or the number of waves or the number of cycles per second is defined as your frequency. Up to this it is clear, I think. So now moving to the next part of the question, that is wavelength. Children, what is meant by wavelength? Wavelength. So, previous classes I have already told you it is indicated with the letter lambda, Greek letter lambda. So, I hope you understood what is time period. For to produce one complete wave, some time we require. In that particular time, how much distance this wave is traveling? The distance traveled by the wave in one complete time period is called as wavelength. I repeat, the distance traveled by the wave in one complete time period is called as your wavelength. So, generally the wavelength is indicated with the letter lambda. Wavelength is indicated with the letter lambda. Lambda is a Greek letter. Okay, the distance traveled by the wave in one time period is called as your wavelength. Okay, so last class I have already told you that distance between any two crests, any two successive crests, any two successive troughs, okay, or a compression between one compression and the rarefaction, everything is a wavelength. Okay, so what are that? The distance between any two successive compressions or any two successive rarefactions or any two crests or any two troughs, everything is a wavelength. Okay, so now moving to the wave velocity. So children, generally we know that in kinematics you study regarding the velocity. What is velocity? Distance upon time. Okay, here also velocity. Velocity means distance upon time. But whose velocity? It's all about wave velocity. So the distance traveled by the wave per second. Okay, wave velocity means velocity equals to distance by time. The distance traveled by the wave in 1 second is generally called as a wave velocity. Okay, so in 1 second some distance it is been traveling. Some may travel travel larger distances. Some may travel larger distances from here to here. Okay. In 1 second, the distance traveled is something like this. But in the same second, the same way, the distance will be something different. So, whatever the distance traveled by the wave in 1 second, that is generally called as a wave velocity. And one more thing, let us have a look into that, children. Amplitude. What is amplitude? So, amplitude means the maximum displacement of a vibrating particle from its mean position. So, this is the mean position. From this mean position, the wave has moved from this position to this extreme position. This to this extreme position. So, this length itself is called as your amplitude. The maximum displacement of a vibrating particle from its mean position. Here also, from here to here, whatever the length is there, this part itself is called as amplitude, indicated with the letter A. Okay, well, and the previously what I had discussed is velocity. What are the units of velocity, children? Wavelength generally indicated, measured in wavelength. SI system, it is measured in meters. Wave velocity measured in meter per second, and amplitude is also nothing but a measure of distance, hence it is also measured in meters. Is that clear, children? So these are all regarding the characteristics of wave. So let us recall back once again. What is a phase? The points on a wave which are in the same state of vibration. The points on a wave which are in the same state of vibration. The time period means the time taken by a wave to produce one complete vibration or one complete wave. So what is frequency? The number of vibrations per second, or the number of waves per second, or the number of cycles per second is called as frequency. SI units of frequency is hertz. Okay, well, SI units of time period is seconds. Now coming to the wavelength. What is wavelength? The distance traveled by a wave, the total distance traveled by a wave in 1 second, that particular distance itself is called as a wavelength. And its value is also equals to, the wavelength is nothing but the distance between any two successive crests or troughs or compressions or rarefaction. It is also measured in meters. Coming to the wave velocity. What is velocity, children? Distance upon time. So here wave velocity is defined as the distance traveled by a wave in 1 second. I can also represent it, the wave velocity, as V, which is equals to, in 1 second, let us suppose that the distance traveled be lambda, then V can be written as lambda by T. So what is amplitude? And okay, units for wave velocity is meter per second. So amplitude. What is amplitude? The maximum displacement of a vibrating particle from its mean position is called as your amplitude. Clear, children? So now let us go with some other relation. This velocity, frequency and time period. Okay, here we go with. Children, one thing you need to remember regarding amplitude is that amplitude directly gives the measure of energy. That means larger the amplitude, larger will be the energy, and lesser the amplitude, lesser will be its energy. So amplitude gives the direct measurement of energy. So next to that, let us also look in detail regarding the relationship between the frequency and time period. Okay? So now relationship between frequency and time period. Here we go. Children, the reciprocal of time period itself is nothing but your frequency. I repeat, the reciprocal of time period is frequency. Suppose if you represent time period with T, then the reciprocal of time period is represented as 1 by T. So the reciprocal of time period itself is nothing but frequency. That means larger the time period, lesser will be the frequency. Okay. Or you can also write it down something like this. T is equals to 1 by yeah. Okay. So as earlier I told you that the SI unit of frequency is hertz. So as frequency is also equals to 1 by T, this can also be written as 1 by second. 1 by second is nothing but your second inverse. Okay. So you have two SI units for frequency. One is hertz and the other is second inverse. So let me write the second inverse as something like this. S inverse, second inverse. Got it, children? So well, also let us also try to understand something regarding the relationship between wave velocity, wavelength, as well as time period. Relationship between wave velocity, wavelength and time period. So children, as we know the definition, from the definition of wave velocity is defined as the distance travelled by the wave upon time period. Okay, so up to the time taken, that is wave velocity is equals to distance travelled by the wave upon time taken. Simply we know that velocity equals to distance by time. So wave velocity equals to distance travelled by the wave upon time taken. So wave velocity let us represent with the letter V equals to distance travelled by the wave. How much is it? A wave, okay, in one particular time period, in one particular time period from here to here, what is the distance travelled by a wave, children? From here to here, the distance we generally indicate with letter lambda. Now, suppose in one time period, if the distance covered by the wave is lambda, then V is equals to lambda upon time period is time taken, that is T. So, V can be written as lambda upon T. Okay, children. Well, but what is the value of 1 by T? So, this is a relation between V, lambda and T. So, relation between wave velocity, wavelength and time period is given as V equals to lambda by T. Not only this, children, this can also be represented as V can be written as lambda times of 1 by T. Lambda by T is nothing but lambda times of 1 by T. But what is the value of 1 by T? 1 by T can also be written as frequency f. Hence, V can be written as, instead of 1 by T, I replace it with f, and this is your lambda. So, another relation between, another formula for wave velocity is V is equals to f lambda, where f is frequency and lambda is wavelength. So, these are the two different formulas we generally use for wave velocity. So, based on these formulas and the concept we have discussed, let us move to the work.